sigma y, sigma x. Sigma y means standard deviation of y, and similarly for x. And the estimate of the slope coefficient is simple. Sample mean of the dependent variable minus beta hat times sample mean of the independent variable. Normally, I don't particularly care about that, but since we're going to do only linear simple regressions, I want to be able to do this quickly for a lot of different portfolios on a spreadsheet. So we're going to use basically these formulas. And in Excel, correlation of x and y is equal to a function called correl x and y. The order doesn't matter. But let's get the data first, okay? We downloaded it last time, but some of you guys were not here, so I'm going to do it again. On Google or your whatever your preferred search engine, type ChemFrench database. That's going to come as the first link. They have return data for a lot of different portfolios, but what you're going to do first, you're going to get, let's see, portfolios formed on size, okay, CSV. And if you click on details, it tells you exactly what it's doing. At the end of June of every year, they sort all the stocks in United States based on their market cap, which is share price times number of shares outstanding. And they put them into what we call decile portfolios. A decile means 10% of, okay? So the smallest 10% is on this decile 1, largest 10% in decile 10. So let's download those. These are monthly. And those portfolios are held for a year, and next year rinse and repeat. I'm going to be interested in these. Let me copy all of these into my spreadsheet. Okay, let's see. I'm going to start about here. June 1926. I think we have it until January of the year. Let me check. Actually, we have February as well. Last week we didn't have the February yet. I'm gonna call this decile 1. So whenever you start a list with an ending 1, and you just grab it, Excel assumes that you're gonna go by ones. These are the monthly returns on portfolios that are evaluated, which means if a stock has twice the market cap of another stock, its weight is going to be twice as that. And these are already in percent forms. So technically speaking, 251 means 0.0251. Values. Apparently, I didn't have all of them. Let's see. Oh, okay. I should have these. All right. So I'm gonna calculate some of these. Mean. Wait a minute. I thought we had until February. Oh, I know what's going on. I should have started with July 1926. Okay. So this says, remember, these are only monthly returns. Over the last 97 years or so, the stocks that are in the smallest 10% of existing stocks have brought in a return of 135 a month, not a year, a month. And the stocks that are in the largest 10%, they brought in a return of about 0.89%. Now, if we were to take CAPM seriously, that would mean that large cap stocks have a much smaller beta, okay? Or, I mean, we haven't looked at the excess returns yet, but assuming that didn't matter too much, the ratio of the beta of the small cap stocks to the large cap stocks should be about 1.5. Whether or not that's the case, we're going to find out. Since we're going to need these as well, let's see. Standard deviation using the function stdev. Well, at least as far as the total risk is concerned, standard deviation, yeah, small cap stocks are much more riskier. Okay, it's about twice as much. One of the first predictions of the CAPM is the riskier a stock, the higher should be the expected return. That part is there. Okay, but it also makes a very specific prediction. How much more depends upon the systematic risk. There is a variable, there are two variables here. We need the return on the risk-free rate and return on the market, okay? Those we're gonna get, let me see where you are. So-called Fama French factors. If you get the details, the RF is, I do believe, yeah, return on 1 month treasury bill, basically. But the market, the so-called market portfolio is the evaluated return of on all firms that are traded in pretty much America. Okay, but it excludes things like ETFs and other stuff. These are basically stocks for corporations. That's what they mean by CRISP code of 10 or 11. And I don't think it also includes ADRs, but doesn't matter. All right, so let's get those. CSV. We already have data on the market risk premium. For now, I'm gonna take these, all of these, okay? So let's take all of these. And let's put the values in. This basically says, on average, over the last 97 years, the market portfolio did about 0.67% more compared to the risk-free rate. If you think about annualized, so that's an effective annual risk premium of 8.34% over the last 94 years, 97 years. A little bit more recent past, it's not that high, but at this point, I'm not worried about that yet. At least on this level, we don't worry about that stuff yet. If this was a graduate class, we would have done a final analysis. Now, the regression model is about the risk premium of the portfolios. So I'm going to actually, let me cut and paste them here.